Hey, this is Ms. Sebastian. We're going to look at Unit 6, Lesson 9's Pythagorean Theorem applications. Okay, so we're going to first look at this example. A 5-foot ladder is leaning against a tree. The bottom of the ladder is 2 feet away from the bottom of the tree. How high up the tree does the ladder reach? So I'm going to draw my tree. Doesn't have to be good, it's just giving me a idea of what it looks like. Okay, here's my tree, here's my ladder, okay, with its rungs. Okay, so we know that this distance here, that distance, it's 2 feet away, and we know that the ladder is 5 feet. We need to know what this distance is. So if you notice, that's a Pythagorean theorem problem. A squared plus b squared equals c squared. So we know one leg, so it'd be 2 squared. We don't know the other leg, and we know the hypotenuse. So we're just going to simplify as much as we can. 5 squared is 25. And so I need to take the 4 to this side. So I've got to subtract 4 from both sides. And I've got to get rid of the squared, so I'm going to take the square root of both sides. And the square root of 21, it's not pretty, but it is about 4.58. Okay, this is the big ugly thing I got. Okay, so that gave us a good idea of how to use that in real life. This one gives us another example. A square garden has a diagonal of 30 feet. Colton wants to put a fence around the entire garden. How much fencing will he need? Well, first we need to find the length of the sides. Well, this is a square garden, so both of these are the same thing. So instead of saying a squared plus b squared, I'm going to put a squared plus a squared because they are the exact same measurement. Okay, so now we have a squared plus a squared, that's 2a squared, plus 30 squared, that's 900. Now I'm going to divide by 2, and I'm left with a squared equals 450. When I take the square root of both sides, the square root of 450 gives me 21.2. So each of these sides is 21.2 feet. If it helps, label every one of them. Okay, so we've got all of those. So all you need to do is multiply 21.2 times 4 sides. So the total fencing he will need is 84.8 feet. Okay, so let's look at our next one. A fishing boat lies 300 meters due south of a large tree on the shoreline. There we go. Okay, and 400 meters southwest of the dock. Okay, so here's the boat. Okay, and it said southwest of the dock, and 300 meters, and this was the tree. Okay, from the tree to the dock is how much? Okay, so not the prettiest picture, but it does give us a good idea. We need a sail. Okay, so we've got a squared, which we don't know, b squared, which is 300, equals c squared, 400. So we can simplify a little bit. $400 squared is 160,000. I'm going to subtract 90,000. And I do get 70,000. Take the square root of that, and I get it's about 264.6, and these are meters. So the length of this is 264.6. Okay. A support cable connects the top of the bridge tower to the road below. The cable is 240.9 feet long and connects to the road at a point 205.7 feet away from the center of the bridge tower. Okay, so we've got our tower here. Here's the road. Okay, and the cable looks like this. Okay, it's holding that up, it's supporting that. This is 240.9 feet. We don't know how tall the tower is, and this is 205.7 feet away. Okay, so we're just going to write it out. We've got a squared plus b squared equals c squared. We know one of our legs is 205.7. We don't know the other leg, and we know that c is 240.9 squared. So I'm going to use my calculator because I don't want to multiply those out. I get 42,312.49, and 240.9 squared is 58,032.81. And I'm going to take the 42,312 and 49 hundredths over to the other side. And I do get b squared equals 15,720 and 32 hundredths. Now, the good thing about having your calculator here is these big ugly numbers you can do pretty easily. So I'm going to take the square root, and I do get b equals about 125.4, and these are feet. Okay, this last one is a little different. It says a rectangular prism is shown. Find the length of BF to the nearest inch. Okay, so we're looking here from the back to the front. Well, what lengths do we need to find to have a right triangle? Well, we have to have these. We have to have the diagonal for the bottom. We have to know the length of this side, which we do. It's 3 inches. And then we can find our hypotenuse here. So the first thing we need to find is this bottom length here. Okay. So I'm going to use this triangle. Okay. I know this back length is 1.5. So I've got my I've got my hypotenuse, and I have, let me try that one more time. I've got my leg, and I've got my other leg, because even though it does not look like it, this is a right angle. Okay, so I'm going to say a squared plus b squared equals c squared. I'm going to plug in what I know. So 1.5 squared is 2.25 plus 1 equals c squared. So when I add those together, I get 3.25. Take the square root of both sides. And I do get c equals 1.8. Okay, so this is 1.8. Now, I have my two measures. Okay, I'm going to trace them in pink so you can see them. I've got this side, I've got this leg, and we're going to be looking for the hypotenuse. So, I'm going to have to do another a squared plus b squared equals c squared. I've got 3, and I've got 1.8. So I'm going to go ahead and square them. 9 plus 3.24 equals c squared. So 12.24. Take the square root of both sides. And I do get c equals 3.5. And this is inches, so make sure to add those measurements on there.